Hi, well we've got a Mia2 that's not charging. There's 12 volt going into it quite happily, so I'm guessing it's going to be this device that's not actually working. So we're about to taste the bits, so I'm going to cut along the edge and have a look, see what's in it. This fits on top of the actual device with a couple of magnets, and it is supposed to charge it. So okay, right, I've gone around the outside and let's see if we can get this thing open. Be interesting to see what it's actually doing, because I thought a magnetic flux had to be AC normally. So let me hold the camera as on it. Okay, and there we go. So it's going to be some sort of coil. I'm guessing there's going to be some sort of circuit on the back. Oh, well, let's lift it out and see. Okay, it looks like it just lifts off with the pins for charging. And there's looks like a little transistor on there. And that looks like it could be the problem I've got. Have a look at that bit there, if we can get it to zoom. Okay, that's a some sort of ferrite or iron core for the centre. You've obviously got the coil. There's a capacitor there, non-electrolytic, and electrolytic one there, which is just going across the power. So a few different views of it. On the back we've got a transistor. It's a bit of a couple of tuned circuits by the looks of it. That's where your 47 microfarad one is across there. That's just a link jumper. The inductor is actually soldered from this point and this point with a capacitor across it, which I think is that one there. A couple of magnets that hold it in place, and the ferrite normally goes into that square between those two squares there, which I presume there's going to be the same on the inside for creating the transformer type charging facility on it, some sort of AC flux across the two. That's actually really honest. The terminals, when you put the board back in, it just slides into those little bits on there, and it's just a 12 volt DC that goes into that, which obviously starts the circuit going to create some surface mount resistors. I did read that one actually originally as 822, but it's actually it is actually 822. I thought it was 228, but it's actually 8.2K. These are 12 ohm, and this one was 1K. So it looks like it's a timing circuit to create AC electric, so that you can get a magnetic flux into the Mia2. Right, what I did now is I powered the oscillator up and stuck it onto a medium wave radio, and from this you can actually hear the charging and the discharging of the capacitors. Maybe a little bit misleading because I've got a tone generator actually connected to it as well, not in circuit, but I was just using the crocodile clips off of it. But I think you can tell it is actually doing something if you listen. As you can hear, it looks like it is working. Listening to it on a medium wave radio. Turn the power off and see if it goes off. Yep. Yeah, it obviously stopped when I turned the power off. So it's definitely picking up the magnetic field from that. I then stuck the oscilloscope onto it, and don't know how many years since I last played with an oscilloscope, but from what I can remember, it was set on 2 millisecond per square, and it's on 2 volt per square, so 4 squares over for one sine wave, and I think it worked out at when I stuck it into a conversion, 125 hertz it was running at. There you go, which is there. So 8 millisecond, 125 hertz. That's what it seems to be coming up as. I might be wrong. As I say, it's a long time since I played with an oscilloscope. That's the kind of the circuit that I drew out from what I could work out from looking at the board. I think it's an NPN without knowing what the actual number is on it, because all it has on it is something like DF. I kind of worked out that I think it's an NPN. That would make sense by this circuitry, some sort of timing circuit. It does look familiar though, but I'll get up the last pictures. The coil inductor was 3.7 ohm. I don't know how many windings, but I don't want to take it too far to bits. And I'll leave that one on the final.